All right, so we're going to do a quick calculator skills video. This is probably part one because I'm sure I'll come up with some other things that we need to cover. You might want to skip ahead to stuff that you're particularly looking for, so I've listed mostly in order the stuff that you're going to see, and I'm just going to go ahead and do some stuff and some things. All right, so first skill you want to have is storing values. This is incredibly useful in calculus. Basically, this is for whenever you have to reuse an exact value, like not rounded, not approximated, not truncated, but exact value. So, for example, let's say for some reason I need to reuse, I don't know, let's say the natural log of 9. I'm just going to give that as an example. So I have the natural log of 9, and for some reason I'm unwilling to type it as the natural log of 9. I've got no good reason for that. This is what I get. If I want to reuse that and not have to type natural log of 9 again, or maybe it's something way more complicated than the natural log of 9, which was pretty fast to type, I'm going to hit stow, this stow button down at the bottom, and then I'm going to pick a letter and do alpha A. And when I hit enter, now A is automatically that number until I overwrite it. If I have a program that it uses A as one of my variables that I am allowed to input, like for instance the quadratic formula, that would overwrite the A that you have stored in your calculator. What you'll find is if you pull up some of the like random letters, like let's say, I don't know, W, it's probably stored as a 0. So your calculator defaults to storing all of these letters as 0. But you can overwrite what they are. So I've probably used B recently, so if I pull up B, it's probably not a 0 because it's from something else I used. That B could be from who knows how long ago when I used either the quadratic formula program in my calculator or when I had to store an A and a B, so I went through. If I'm doing this on a test and I need to use a value again, and maybe the reason natural log of 9 is not a great example is because it's easy to type natural log of 9. Maybe my number that I'm storing is something like the natural log of 2 plus, I don't know, 4 squared minus 9 divided by 3. Great, okay, cool. And it's this. And I don't want to type that every time. So instead of having to type it every time, I store that as, let's just say, alpha C. You're going to want to make a note on your paper if you store something as something else, like you want to call it that, especially in calculus when you're trying to get that sweet AP credit. If you use, if C is approximately, so let's say my C was this natural log of this horrible mess and I just don't want to type it again, and I type it in the calculator and I get 2.708. And I'm going to go ahead and say that is C. And I'm going to call it that. And then if I use C later in the problem, I'm referencing that value. But notice that what I'm using in my calculator, and actually, I take something back real quick. Let me fix it. If I'm going to have to use it again, I shouldn't put the approximate answer. So I should put the whole thing. So 050201 ... is approximately my C. And then in a final answer, I could round or truncate it to the thousandths place. But if I'm going to have to use it again, I want to use the whole number. If you don't do the storing thing, then you basically have to type that entire giant number in every time, and that's just not fun. Nobody wants to do that. All right. Changing modes. So in general, in math, you're going to be in radian mode. So if you go here on your calculator, here, I'm going to clear this off. If you go here on your calculator, you'll see a mode button. Normal, scientific, are ones that you might see sometimes, although usually we just stay with normal. Float is how far your calculator rounds. So if you float to 0 places, then for instance, this answer I had here, floating to 0 places, would have rounded to just a 3. You don't want that. You want to be the one in charge of the rounding in your calculator. You don't want your calculator to do it for you. Radian mode is generally what you're going to use in math class. Degree is usually going to be in science class. There are exceptions. If you're sitting in like a geometry class, you might be doing a lot of degree stuff, or sometimes if you're doing a particularly physics heavy unit in math class, you might be doing some degree stuff. And then the next line is function, parametric, polar, and sequential mode. Function is really the most useful of all of these. We're going to use it most of the time. It has all the cool bells and whistles that are really useful, but parametric and polar are going to be useful sometimes in pre-calc usually, or especially in BC calc. And then you don't really have to worry about a whole bunch of the stuff that's underneath here. For real and imaginary, so that's the real mode and the A plus BI mode, those come up sometimes and they're sort of useful, but really they're only useful in the section of Algebra 2 where you learn imaginary numbers. I would suggest you leave it on real because you want your calculator to alert you if there's no real solution, because most of what we do in calculus involves only real numbers, so you'd rather your calculator be doing that. So if you wanted to change to any one of these modes, let's just use degree as an example. I'd go down to degree, I'd hit enter to switch the highlight to degree, and as you can see, the thing that's highlighted in black is the one that it's on. Now I'm going to switch back to radian because I almost always doing calculus here, and radian is the better plan. So that's how you switch modes. Recalling your last entry. So let's quit out of this, which is going to be the next video. I should put it earlier. Let's say I want to pull up the thing I typed last, which was probably pulling up that store as C. I hit second enter. And if I hit second enter again, it'll go to the one before that. And if I hit second enter again, it'll go to the one before that. Why this is particularly useful, it's very useful if you either realized you made a typo in a long thing that you typed right before this. So if you hit second enter, you can go up and you can fix it. Like maybe this wasn't a 9, maybe it was supposed to be an 8, I don't know, whatever. Or it's really useful if you're using the same skill over and over again and just changing particular values. Like if you're using n-derive, which we're going to get to a little bit later in this video, and you only have to change, let's say, the bound that you're, or the point at which you're differentiating, or maybe you're using a function integrate and you have to change the bounds that you're integrating between. Those are really the only times that it's a total waste of your time to retype something, right? If you're using the exact same function again and changing one minor value, sorry, small or minor is not minor. It's been a long, long week. So if you're changing one tiny thing, it's really not worth going back and doing everything from scratch. It makes more sense to do second enter. So, and the next one is probably how we quit out. Hey, look, I just did that. Okay, so if I go second and then quit, oh, my bad, hang on. Second and then quit, it'll quit me out. Now here I'm already on the quit screen, so that's not helpful. But let's say that I am in a matrix. So let's say I'm in a matrix, and I'm matrix, and I go over to edit, and I give myself a matrix, and I make it 3 by 3. I don't know, just so I can put some numbers in. 2, 3, 6, 5, 4, 1. I don't know, 2, 9, 8, doesn't matter. So I don't want to hit clear to get out of here, because if I clear this, what's going to happen, and you'll see it in a sec, if I clear it, it just clears the 8. And that's not what I meant. I wanted that to be an 8. In order to get out of a screen where you're doing something on the calculator, whether it's matrices or a graph or a program, like if you don't want to accidentally clear a program you've just written, because boy is that no fun, you quit out. And the way we quit, you can see quit is listed right above the mode button, is we press second and then quit, and it'll get me back to the home screen, right? So again, whatever I'm doing, if I'm in here and I want to get out, I do second quit. If I'm in a graph and I want to get out, I do second quit. If I'm in my table, right, if I'm at stat and, oh, my bad, I meant to go to stat, and I'm at edit, I'm in my table, and I want to get out of here without accidentally clearing data, I quit out, so second quit. That's a really useful skill. That's what I mean if on a video I say quit out. All right, let's do some graphing. So first thing we want to do is we want to make sure all our plots are off. So you can see the plots here at the top. A plot is on if it's highlighted in black like this. Right? So I want to keep that off because I'm not trying to plot things. I'm trying to graph something in my y equals. And then I'm going to put my equation in y equals. I'm going to use this variable button, which is x comma t comma theta comma n. So I'm going to do x squared minus, oh, that's not a minus, my bad, minus 5x plus 2, right? And then I'm going to go ahead and I'm going to zoom 6, because zoom 6 is generally our friendly window. So I press zoom, and I want zoom standard, which is zoom 6, and there's my nice happy window. I know that this is a parabola because it's an x squared. I know I should see that it's a smile, right, because of positive x squared. And sure enough, that's a pretty good window on that graph, so I don't need to adjust the window at all. That's how I graph. Again, if I had had a plot on, I might get an error. I might not. There you go, error invalid dimension. That error invalid dimension, and we'll talk about this a little bit later on towards the end of the video when I do troubleshooting, but error invalid dimension doesn't give you the go-to option, which is rough because you just have no idea where the mistake is. Disproportionately, it's that you're trying to plot things that don't exist. Because if I go over to my stat and I try to edit my list, it was trying to plot my lists. There's nothing in my list, so the calculator's trying to plot something that doesn't exist, and that just made it really angry. So I'm going to go up here and turn off the plot, and then you'll see that I'm able to graph easily. All right, adjusting the window if your graph doesn't show up in the window. So this one, the graph showed up perfectly. We saw the parabola we wanted. In this one, I'm going to go ahead and second insert so I don't have to retype the x squared. So I did a negative. I'm going to change this to a 10, so I put a 1, and then I'm going to second insert a 0, right? And then I'm going to make this a minus 5. Make sure you use subtraction with the 5 and not a negative, because that would give you a different answer. Now I'm going to go ahead and graph. I'm zoomed 6, and uh-oh, I don't see what I want to see. I can see from the x squared that's negative that this should be a frown. And I see that it's a frown, but I can't see the top. Since most of the time the thing we care about is seeing the roots, and I can see both of the roots here, and the extrema, which I can't see the top, I need to change my window. So I'm going to go to window, and in this case, the thing I want to see is higher up. So that's y max. So I'm going to go to the y max, and I'm going to change it from a 10 to like a 20, which is probably enough for me to see the top. And there it is, just barely. Like honestly, I'd probably change my window to go a little bit higher because it was cutting it a little close. I might go to 30, and that's a nice window, right? I can see both of the roots. I can see the extrema that I would expect to see, and that's kind of the goal. So that's how we adjust our window. in general, start with zoom 6 unless you have a very specific reason not to. Like if you're doing a word problem where all of the values are in the thousands, then maybe it doesn't make sense for your x's and y's to be from -10 to 10. But in most cases, start with zoom 6 and then adjust manually. If you just do the generic zoom out, so I'm going to zoom 6 again. If I just generically zoom out because I want to see the top, that's hit or miss. It's sort of like zooming out on Google Maps, right? So I hit zoom out, it didn't do it yet, it's flashing right here, and I want to go to kind of where I want it to zoom out, right? And it seems like I want it to zoom out kind of over here, and then maybe up a little bit. I want to see that. Now, this might work, it might give me a great window, it might give me a crazy window. We're going to find out. But when you zoom out on like Google Maps, sometimes you're able to still see what you want, and sometimes you're like, nah, bro, why'd you zoom out that far, right? So using zoom out and zoom in generically is hit or miss. Sometimes it's great, sometimes it's not. It's why I always prefer to adjust my window manually. And there, my zoom out gave me what I wanted, but it would make it kind of hard to find the zeros, right? I'd have a hard time finding the roots. I can see the max, but that's a very zoomed out window. So again, cautionary tale, I don't think zoom out and zoom out in are the best fits. I think it makes more sense to start with a zoom 6 and then manually change the window to match your needs. All right, let's do another one. So let's talk about finding some zeros. Now conveniently, I already have this one in the calculator, so I'm not going to bother to put it into y1 again. The zeros are these two spots right here. Zeros mean where the y value is 0, so the graph hits the x-axis. To do that, I'm going to go to second calc, and I'm going to pick 0. So I'm going to go left of this 0. So I'm going to go with the one off to the left first. So I have to do this process twice. So see, I'm scrolling over. My cursor disappeared up at the top of the hill for a little bit. Scrolling over, it's coming down, there you go, it's at 9 now. Okay, so now I need to go left of the 0, which means I need, because left of this in this case would be below the x-axis, I need to cross the x-axis. All right, that point is left of the 0, so I hit enter, and you can see the calculator's doing me a solid and telling me I want left. I hit enter, and now it has an arrow that points and tells me, hey, in case you don't know your left from your right, this is right. So now I need to cross the axis. I can just cross to make y positive, or I could go a couple clicks, it doesn't matter, and I hit enter. And then for the guess, you just hit enter, it's fine. And this is my answer. Now you'll see that what I got here is the x value, -9.472 would be my 0, and the y value should be 0. And you might be saying to yourself, but Hogan, why is 2e -12 a 0? So why is this a 0? Well, remember that this is scientific notation. It means a 10 to the -12th. So this is a 2 with the decimal here that is moved 1, 2, 3, 4, 5, I'm going to run out of room, 6, 7, 8, 9, 10, 11, 12. Oh, that's where the decimal is. This dude's a 0, right? Like this is definitely a 0. This is a lot of zeros in front of that 2. So this is definitely a 0. So the x value I'd want is this -9.472136. Now, notice this extra step right here. This is where we kind of tie some skills together. It's very useful sometimes to have this value for later exactly. So what I can do is I can quit out. So notice that we have this number. So right now I'm just going to make a note that this first number, the first 0 we have was x was approximately, I want to show you for sure that this skill works. So this is the number I should be getting. If I quit out and I hit the x button, x is currently stored as that 0. There you go. So what I can do is I can store that as alpha a. Now if I need to use that 0 later, I can be like, yo, I called that 0 a. Because in calculus, sometimes you're going to have to use this again. Now if I go back to my graph, I need to find the other root the same way. So I'm going to do second calc 0 again. And I'm going to scroll all the way up over the hill. I've disappeared at the top because my y values are too high to be seen in this window. It's because I never adjusted the window back again. That's fine. Here it comes. There's the cursor. Now I need to be to the left. Well, I'm currently to the left because if you look at this curve, I would have to hit right to cross the axis. So I'm currently to the left. I'm going to cross the axis and hit enter. That's my right. And then I'm going to guess. And so for my second one, right, my second root, I get that x is approximately -0.527864. And I'm going to call that b. So again, I'm going to quit out. I'm going to hit x. Now notice last time I hit x, I got the other x value, but this time I'm going to get the most recent x value that it was stored as, and I'm going to stow this as alpha b. And so now, if I have to use these again, if I had to use the a or the b in, let's say, calculus to find the area between, the area under the curve between those two values or something else, I would be able to do so. So again, that's putting the pieces together of being able to find a 0 and then store it if I need it later. All right. Finding extrema is the same kind of idea. So I gave us a new graph. It's going to be x cubed minus 5x squared plus 6x plus 9. So let's go back to my y equals, and we'll clear this guy out. So we're going to do x caret 3 minus a 5x squared plus a 6x plus a 9. Right? And let's see how our graph looks. We're zoom 6 already, but just in case. Okay, so this is a great example of where I'm going to have to adjust the window because I know what a positive cubic should look like. I know that a positive cubic should look like this. And I'm currently seeing this, but I'm not seeing this. So I need to adjust higher. So I'm going to go to window, and I'm going to make my y max, I don't know, let's do like a 20. I'm guessing that's enough. Hey, that's a great window. So now I need to find the max and the min. You have to make sure you select the one that you're actually looking for at the right time, or else your calculator is going to give you the wrong answer. So I'm going to start with the max. I always work from left to right, so in this case, the left one is the max. So I'm going to do second calc, the calc that's up at the top, and then I'm going to pick 4, which is max. So I need to go left of the top. So the easiest way to do this is to scroll up until I think I've hit the top y value. 11, yep, this was the highest one around. That doesn't make it my answer, but it means that now I need to go left of it. So I'm going to go left, left, couple clicks, and then enter. I need to go back up over the top till I start dropping down again, hit enter, and then for the guess you can just hit enter again. So now I get that this max is approximately 0.787, oh, not a 7, my bad. Sometimes hooked on phonics didn't work for me and I'm bad at reading numbers. All right, 491. Okay, so it's approximately this, but I'm going to go ahead and store this in my calculator as, let's say, A. Sometimes you need the y value at the point of intersection. It depends on what you're being asked to find, right? Sometimes you need the y value, sorry, not point of intersection, at the max. So if you were asked, this is where the max happens, and this is the actual max value, right? So if I wanted to store these, right, let's see what happens if I quit out of here. Let's say I wanted to store that as A. So if I hit my X again, it should be the thing we just stored, and sure enough, there's the 7.84 blah, 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 and I could store that as alpha A. Let's say that I also wanted to store the y value. Let's see if this works. I'm going to hit alpha, and then y is a little harder because it doesn't have its own variable key. Sorry, I meant alpha 1. There we go. And sure enough, that's exactly what I need it to be. So I could store that as, let's say, C, right? Let's say I decided to make this C. Let's say I said, hey, this y value is C. Maybe I need to use that y value again, and I'm able to do that because y is overwritten by the 11.112, et cetera, et cetera. If I go back to my graph, I can do the same thing with the minimum. So I'm going to do second calc, and then minimum is number 3. Again, I'm going to go to where I think the minimum is, and I can judge that based on the y value. So I want the y values to be getting lower. It seems like that 8.36 is the lowest I can go. Since it says left boundary, I go a couple clicks to the left and hit enter. Then it says right boundary, so I go past the bottom, a couple clicks to the right and hit enter, and then I get my value. So now again, my x is going to be overwritten, right? So my minimum is going to happen at x is approximately 2.54809, which I'm going to store as, let's say, B. And the lowest value, that local minimum, is going to be 8.3688697, right, approximately. And I'm going to store that as, let's say, D, right? So I have the point A, C, and the point B, D. So if I did that, I'd quit out, and then sure enough, when I press my X, it's going to be exactly what I expect it to be, and I could store that as alpha B, right? And when I press my Y, which is a little trickier because it doesn't have its own special button, I get that, and sure enough, that's the minimum we got, and I'll store that as alpha D. This is so if I need to use those values later, I have them. In algebra, you're not really going to have to use them again. In algebra, you could just put your answer to the thousands place and probably be done. But in calculus, you're very often going to have to use those boundaries again, use those maxes or mins or intersections or zeros, and so this is a really good skill of knowing how to quit out of something and then use the x and the y that you get to store it. And in this extra step down here, I only described doing it with the x, but as you can see, it also works with the y. All right, we're going to reuse that first equation we have because it's already in the calculator, which is nice. And I'm going to put a second equation in. So I'm going to have a negative. Notice that's a negative, not the minus. And then x minus 2, that's the other button, squared, plus a 10. Now this time I want to find the point of intersection. So I'm going to graph this. And I'd already adjusted the window, so that's good. And I can see that these things intersect 1, 2, 3 times. So to do second calc intersect, I go second, I press the trace button, which is calc, and I go to 5 for intersect. The nice thing about intersections is you literally just have to go to the spot where they run into each other and hit enter 3 times until it says intersection. Now again, if I wanted to store this first intersection as, let's say, A comma B or A comma whatever, I could store the x as we've seen in the other video, right? I could quit out, the x would be this value, the negative 0.618, et cetera, et cetera. The y would be the 3.14, blah, 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 blah. To find the next point of intersection, I go through the exact same skill again. Second, calc, and then I pick 5, which is intersect, and then I go to the next spot where they seem to run into each other, which is about there, and that's the next one I want, right? The x value is 1.618031, et cetera, and the y is 9.854102. And notice I'm done when it says intersection. Lastly, I'll find second calc intersect. For the last one, I scroll over to where I think they hit, and there you have it. That one's nice. It's 3, 9. So that's it. All right, and that one's no rounding or anything else, and there's not really a point in storing it. Okay, so sometimes we want to find a specific value in a curve. So let's go ahead and I'm going to delete this second function because I don't need it, and I've been reusing this first one for a while, so it's that same first function. So let's say I want to find f of 1.3. I can do that by hitting this, by hitting this trace button. And see, trace starts me at 0.9, but if I hit trace and then I hit 1.3, it will jump me to where x is 1.3. And you can see that when x is 1.3, my y value is approximately 10.547, right? So that's kind of cool. Now, what I will say is that it has to be someplace that you can visually see on the screen, right? So for instance, in this case, I gave you f of 1.3, which we can see on the screen. But what if I'd given you f of, I don't know, let's say I did f of negative 4.1. Well, you can see right here, 1, 2, 3, 4. I can see 4, but I can't see the y value down at 4. So if I hit trace and do negative 4.1, we're going to see what happens. Oh, it did give it to me. That's nice. So it does give it to me if I can't see the y value. What it won't do, I believe, and you can double check me on this, or we'll double check it together right now, is I don't think it'll do it if I don't include the x value. So I think if I try a trace that's higher than 10, for instance, here I said 16. So let's say I tried to do trace and I did a 16. I think it might give me an error. Right. So the 16 is not in my window, so it gives me an error, and I have to go to the issue, right? 16 is, the issue is 16 is over here, which is not part of my graph. So I would have to change my window. Let's say I made my x values go up to 20. Now if I hit trace and 16, it should jump me to the right answer. So like f of 16 would be, it's not even approximate, it's 2921, right? So you have to have the x be in that window, which I described up here, but I wasn't sure if it would work if the y value wasn't in the window, and now we know that it does. All right, so now we're going to do a little bit of calculus-specific stuff. We're going to talk about how we integrate on a calculator and differentiate on a calculator. So if I want to differentiate on a calculator, I want to find the derivative of something, I can't make my calculator differentiate even an easy equation just in general. Your calculator can't differentiate x squared to get 2x, which is silly because that's an easy derivative. But your calculator can do the ugliest derivative you've ever seen at a particular point. It doesn't find the derivative without the value being inputted. It can't find f prime of x, it can only find f prime of a, like where a is a number that we're given. So I'm going to use this function, f of x equals 5x, the square root of the quantity x minus 3. So I'm going to go to y equals, and I'm going to clear out the one I've used a bunch of times now and do a 5x square root of an x minus a 3, right? And I'm going to quit out, and what I want to do is I want to use n derive, which is math, and then 8. So n derive, I want to put in y1. Now, I could just type this whole ugly equation, but the ugly of the equation is, sorry for the bell, the uglier the equation is, the more likely it is that you're going to mess something up. So it's easier to use just y1. So I'm going to press vars. I'm going to go over to y-vars, okay? And I'm going to pick function and y1. Comma is this button right above the 7 with respect to x, because that's my dx, right? At the value of 10 is the example I gave you here. And I hit enter, and there's my derivative. So I'm entering this in. Now, some people's calculators look more like an actual derivative. They look more like d blank. It's the same skill set. The reason I focus on teaching you this one, right, the reason I focus on teaching you this ugly thing right here is because you might have a calculator that does the nice intuitive thing, and that's great. But if your calculator doesn't do the nice intuitive thing, if your calculator is the older school version, you need to know this version. If your calculator dies in the middle of an AP and you have to borrow one of my calculators or one of the calculators that's available at the front of the room, and that calculator doesn't have the form you're used to, I want to make sure you're comfortable with the more difficult form. I think you can intuit this form, but it's hard to intuit the other one, right? So that's the idea. Let's do 2 more skills, I think, and then we're basically done. So we're going to do integration, same idea. So we have an integral, right? So I'm going to go ahead to my y equals, and I'm going to put in this function I have here, which is an x to the 3rd plus a 2 root x, okay? And I want to integrate from 2 to 7. So what I'm going to do, I'm going to quit out. Oh, my bad. I'm going to go to math 9 for function integrate. I want to put the function I want to integrate, which is going to be vars over to yvars function y1, comma, with respect to x, from lower bound, which in this case was a 2, to upper bound, which is a 7. And I'm going to hit enter, and it's going to integrate for me, and I'm going to get that this is about 6.1, or sorry, not 6.1, 617.172. And that's my value of the integral. So again, this is more complicated because if you've never used this before and it happens that you need to use a calculator doing this on a test, you need to know this skill set. This one's fairly intuitive because it looks like an actual integral and you're just plugging in the values. So that's kind of the idea of how it works. All right, some quick troubleshooting, and then we're going to do two kind of examples where we put it together for calculus. So if an error pops up with the option to go to, you should pick that. So an example of that, and I'm going to intentionally make something not work. I'm going to just make this a 9x, but I'm going to go down to the bottom, and I'm going to type some gibberish. Okay, I'm going to quit out. Now I'm going to try and graph. My calculator is going to graph, and then it's going to flip out and say go to. I'm going to go to because it's going to take me to the problem. Anytime an error says go to, so again, if I quit out and I try and graph, see how it says quit or go to? Given the choice to go to, I should go to because that's going to take me to the error. Oh, it was because there was a bunch of gibberish in the bottom, and now it should graph just fine. Okay, so sometimes the issue is that you gave yourself a window with impossible dimensions. So let's go to my window and let me intentionally screw it up. So let's say my window, I accidentally, without meaning to, I make this a regular 10, and I make the x max also a 10, and I graph. My calculator is going to say, oh, there's an error in the window range. Now this one doesn't give you a go to, but they do say it's the window range specifically. So there's a couple ways to fix this. One is if you feel like you screwed up your window and you have no idea how to fix it, right? So like if you think that there's something wrong and you can't possibly figure out how to fix it, you could just zoom 6. That's an easy way to fix. So if you're like, I don't see what's wrong with my window, something is clearly wrong because they told me something is wrong, just zoom 6 and then start back from the beginning and adjusting your window. Otherwise, sometimes it's that you actually, oh, and this is the one where I listed, sometimes you accidentally type gibberish somewhere where you meant to type like 5x plus 6, but you typed 5x plus 2 sign and didn't put anything in the sign, and your calculator was like, no, that's nonsense. You have to fix it. Sometimes, and we saw this error earlier, sometimes the error is that your plot is on and there's nothing for your calculator to plot. So you try to graph it and it gives you invalid dimensions because there are no things to plot. So your calculator is mad, and so the answer to that is disproportionately to go to your y equals and to go up and turn the plot off. Sometimes you have an error in finding a root or a 0, and I'm actually going to do it on this very basic graph. The 0 of this should absolutely be 0, right? Because it's 9x. If I plug in y equals 0 and solve for x, I get x is 0. So I'm going to do second calc 0, which I wouldn't need a calculator to do, but I'm intentionally going to screw it up. So I'm supposed to be to the left of the 0, which would be over here. But let's say I accidentally think I'm to the left and really I'm to the right. And then I say, oh, go to the right of that. Okay, I'll go to the right. And I guess, and my calculator's like super mad because I didn't go to the left and to the right of the 0. It says error, no sign change. So that's the mistake. The other way that this could happen is if I go back to my graph, if I do second calc 0, right? And if I get my left and my right reversed, which has happened to me more often than I'd like to admit in my life, so I accidentally did right first and then I did left because I was confused, and then it's like, yo, that's completely wrong. So then it doesn't give you an error sign change, it kind of gives you an error, you failed kindergarten, and I feel bad about myself. So it is what it is. All right, so those are some common errors. There are other errors that come up, but those are the big ones, right, that tend to trip people up. Oh, one other really interesting thing. I'm going to show you this. It's not listed on the error thing, but it causes people a lot of problems when it happens. It doesn't happen all the time, but it does happen sometimes. And when it does, people get all befuddled. So I'm just typing like a really ugly equation on purpose. I don't know. Cool. Fine. Okay. So I'm going to hit graph, and before it can finish graphing, I'm going to hit, oh, it graphed really fast. I need it to be uglier. Hold on. We need it to be like really ugly for this to work. Minus the square root of, I don't know, let's do x plus 2 divided by x squared minus e to the tangent of x. I don't know, this should be pretty ugly. That's intentionally ugly. So I'm going to graph and hit enter. It's still too fast. Okay, So the short version of this is that if your graph takes a long time to graph, and I'm trying to think of a good example of something that would take like a just hideously long time to graph. When your graph is graphing, when it's thinking, because this graphed way too fast, when your graph is thinking, it gets this little like short, it gets lines that look like this. So I'm going to show you, I'm going to draw it because I can't seem to get your calculator to think. Maybe the calculator's just way too fast. When your graph is thinking about graphing, it gets these long scrolling lines here. Like they scroll and they're like long dashes. That's when your graph is graphing. If you accidentally hit enter in the middle of graphing, it changes from the long dashes to tiny little dots that are scrolling. And if those tiny dots are scrolling, what you've done is you've paused the graph, which doesn't sound like a big deal, but it is because you 100% think you broke your calculator because you're looking at a half a graph and no button you press is working. Quit out doesn't work, and this is one of the few instances where quit out does nothing, and you're just freaking out because your calculator is not doing anything and it just seems frozen and people don't notice the little dots in the corner. If this happens, you need to hit enter because what has happened is you accidentally paused your graph, right? And you paused your graph and your graph is thinking, and so it stopped while it's paused. And if you hit enter, it'll finish graphing and then you can go back about your business like a normal human, okay? So that's just a really common mistake that happens, and when it does, people panic. And I couldn't come up with a complicated enough graph to make it work, so there you have it, excuse me. 2 more things and then we're gonna stop. I apologize, it is dry in this classroom. So, last 2 things we're going to do. Let's put some pieces together. We're going to find the point of intersection of 2 graphs, 2 points of intersection, in fact. And we're going to find the area between the curves, which is a calculus thing where we'd use f_int, right, where we use function integrate. So, my first curve is negative x squared plus 3. My second curve is a 0.5 x minus 6. So I'm going to zoom 6 because we should always assume zoom 6. Hey, look, it's beautiful. So what I've got here is I've got a graph, and I'm just going to do a terrible recreation of this because it's easier. I've got a graph that looks kind of like this. And the area I'm being tasked to find is this. The way I'm going to find that, and the curvy thing, I know the curvy thing is the parabola, so this is my f. And I know that the line is my g. So basically, I need to find these 2 points of intersection. And what I'm going to do is I'm going to integrate. So we're going to call this x equals a, and we're going to call this x equals b. What I'm going to write down when I'm communicating understanding is I'm going to write that this area is the integral from the point I'm going to find that's a to the point I'm going to find that's b of my f of x minus g of x, which I can absolutely call f of x and g of x instead of writing their functions and risking not distributing a negative properly because they called them f and g. So what I'm going to do is I'm going to start by doing second calc intersect, right? So second calc and then 5. And I'm going to find this first one. And it really bothers me that it's under the words first curve, but I'm okay with it. Okay, so I get this value and I need to store this. So I could write the negative, so like I could go ahead and write that a is approximately negative 3.260399. I can write that, but I need to store it. So I'm going to quit out, second quit, just like we saw. I'm going to hit X, and I'm going to hit stow alpha A. And now that's my A. And when I use it in my calculator, I'm going to get to use it. So notice, it's important that I have to write this even if I'm using my calculator, right? Write this because they're not giving you credit for calculator notation. I need to write this, and I need to write what my A is, and I'm going to have to write what my B is. So let's do that again. We're going to go ahead and graph, and we're going to second calc intersect again. But this time we're heading to the other one, okay? So I'm going to go over, and I could have done that faster if I'd switched to the line instead of the curve, but it's all right. Okay, so I get my intersection, and I see that my B is approximately a 2.760396, right? I need to write these things, and then I need to write my integrand. So I'm going to quit out again. I'm going to hit X, and I'm going to store that as alpha B. Make sure you pick the other letter. So now, the thing I'm going to type in my calculator is math9, which is my function integrate. My vars are y1, because I called this guy my y1, right? This was my y1 and this is my y2. I always put them in the order they appear in the problem so that I can never forget which one's which if I'm in trouble. Because boy, does it stink to get the wrong answer when you've done all the actual math right and you just type stuff wrong. So y1 minus y2, comma, with respect to x from alpha A to alpha B. I'm not doing the integration by hand. The calculator's doing the heavy lifting, and I get that my answer is that the area is 36.375 or 6 Because that's my final answer, I can round or truncate. I don't need to put all the digits. So that's the idea. So notice we're putting the pieces together. We had to know how to find the point of intersections of those curves, which is an Algebra 2's calculator skill. We had to know how to store the values, which I would argue also Algebra 2 calculator skill. And then we had to know how to do integration, which is definitely a calculus. All right, so last one here, just going to put the pieces together a little bit. So let's say we are given a velocity, v of t, of a particle, and we're asked what is the acceleration of the particle the first time it is at rest. So the first thing we want to do is we want to put our, we want to go ahead and put our y1 in as our velocity, right? We're using x instead of t. So I'm going to go to my graphing right here where it says y equals, and I'm going to go ahead and put in my e, so e to the t, right? But my t is really going to be an x here, close those parentheses, minus a 3t, but I'm going to use x, caret for the exponent to the 0.125, close the parentheses, minus a 2t, but again I'm using x squared, and then plus a 1.2. And then I'm given the domain restriction that we're talking only when t is greater than 0. So good to know. Okay, so if I graph this, oh, my bad. Let's go to my syntax error. See, that's why you go to. Oh, I didn't need that parenthesis. My bad. So there you go. That's why you have the go-to error. So here's my graph. So it looks to me like this thing has two spots where the velocity is 0, one right here and one right here. But they said the first time. Now, I can't be 100% sure that there's a root right there, so this is a good time to generically use that zoom in if you want. Like you can kind of scroll over and be like, hey, I'm pretty sure there's a root there. Yep, you see there is. There's a little teeny root right there, right? And it's so I can see that the graph is above the axis and then ends up below the axis. It might be hard to find this root, but we're going to do it. So I'm going to do second calc 0, right? And then I need a spot that's left of this. So I'm going to go past, so you can see that I'm above the axis now because y is positive, so I'm going to hit enter. Then I'm going to go negative, and there's my y that's negative. I hit enter, and I hit enter again, and there's my root. So I know right away that the x in question, right, the time that I care about, is, here we'll change colors here. I know that that root, that time when v of t is equal to 0, is going to be when t is approximately 0.11838513, which I'm going to call a. So I'm going to quit out of here, second quit, right? Pull up that x, and that should give me the value I want, and I'll store that as alpha a. So now I called it a. The trick is, and I guess maybe I should have avoided a because of acceleration here, but the thing that we want, right, the thing that we want is we want v prime at a, which my calculator can absolutely do for us, right? So to find v prime of a, I'm going to use my calculator to do n derived. So I'm going to go ahead and do math 8, which is n derive. I want to differentiate the function I called y1, so I go to vars, y-vars, over to function, and I pick y1, comma, with respect to x, which is t, but we're using x for t here, and then at alpha a, right, at the thing I called a, and I hit enter, and that's my answer. So this acceleration, my v prime of a, is negative 1.77, and in this case, I can round or truncate because I'm done. So they didn't give me units here because I didn't give you a unit with meters or seconds, but if there were units, I would have to say something like meters per second squared. So this is the acceleration the first time that the particle is at rest, right? And if there were units, I would use them. But notice how little actual math I did with my hands. Like, it's really important that on these calculator sections, we know how to use the calculator to the maximum advantage, and we do the math part ourselves. We need to communicate. Like, it's my job to communicate that I want v prime of a. That's my job. I need to say I understand the acceleration is the derivative of velocity at this point. It's my job to find the point A using the calculator. I need to know what I'm looking for, but there was no way I was finding that root without the calculator, and there's no way I'm doing that derivative comfortably in any sort of a helpful way without a calculator. Cool. All right, that's it.